Now, today's topic is forms of energy, Mm, and we will discuss different types of energy. All right, different energy is in different forms. We will discuss briefly discuss on those, and we will keep our discussion as very basic. Now, coming to introduction, all of you know the word energy comes from a Greek word called energia, and energy is a quantitative property, right? So it can be quantified, right? Energy, if you talk about energy, energy can be given a unit of joule, kilojoule, uh, right? So many different units are there to measure the energy, different types of energy. We'll discuss later on. Energy could be transferred from one body to other. So in the diagram itself, if you can see, different participants are there. This energy transfer, it is depicting an energy transfer. So it can be done from one body to another. So energy transfer could take place with or without contact too, right? So it is, if two bodies are in contact, then also energy transfer is possible, and without this is also energy transfer is possible, right? So one example could be sun. We are not in contact with sun, so it is transferring energy. Energy could be recognized in form of work, heat, or light, right? So different forms of energy, they are there, right? Energy, all of you know about the principles of thermodynamics. Energy could neither be created nor be destroyed, but it can be transformed from one form to another. Let us discuss about different forms of energy. So forms of energy, all of you know about thermodynamics laws, and the energy transformation takes place from one form to another. So according to laws of thermodynamics, it's apparent, right? Energy can neither be created or be destroyed, but could be transferred from one form to another, right? So you can see all this transformation. Sunlight is converted by photosynthesis. It's converted into chemical energy, right? So primary source of sun energy on earth is radiant energy, which is the sun. All of you know this fact. Then there are two basic uh, energy forms of energy, that is kinetic and potential, right? So kinetic energy is one basic form, and the other basic form which is there is potential energy. Apart from that, we have energy like mechanical energy, we have chemical energy, electrical energy, nuclear energy. All these different forms of energy we have, right? We can discuss about, now we will discuss about kinetic energy. So kinetic energy, if you say, it is basically due to virtue of moving, being able to move, right? So it is possessed by moving body, right? So energy is which is possessed by moving body is called kinetic energy. So work must be done on object to change its kinetic energy. So you consider yourself cycling, right? If you paddle hard, you will move hard, you will move faster. If you paddle slowly, then you will move slowly. So work must be done to change the kinetic energy, right? So kinetic energy is given by formula half mv square, where m denotes the mass and v denotes the velocity. So this is the formula which we are using for derivation calculation of kinetic energy. Or the kinetic energy is usually measured in joules, right? So examples is running of athletes, blowing wind, aircrafts, etc., right? Jogging, all these activities you can see in the figures. Meteorites moving, airplane moving, all these are nothing but kinetic energy. Now discuss about potential energy. Potential energy is which is due to its position, virtue of its, by being virtue of an position, it is having a energy, right? So you can see the water stored in dam will be a source of energy, right? So this is called a potential energy, and potential energy is usually due to influence of gravity on the object, right? So gravity pull is responsible for potential energy, and potential energy can be both scalar and vector quantity, right? It can be scale and it can have a direction also, right? Because uh, uh, it is denoting acceleration due to gravity. So direction is both is there. Now potential energy is expressed in form of mass into gravity into height. M is mass, G is gravity, acceleration due to gravity, and H denotes the heights in meter, right? The common potential energy which is there are include gravitational potential energy, or elastic potential energy, and the electrical potential energy, right? So field electrical charge in a field, so they also have a potential energy or potential difference, which is called as voltage, right? So this is there. So these are different forms of potential energy. In the diagram itself you can see different types of potential energy. Arrow in a bow, okay, a catapult you can see in a dam, right? So all these are nothing but potential energy, right? Mechanical energy. Mechanical energy is associated with motion of the object, right? So object is moving, a machine is moving, right? Or that is used to do some useful work. It is called mechanical energy, right? It is either influenced by potential and kinetic energy. On the diagram itself, you can see a hammer being used to nail down, right? So please mute your mic. So hammer is being used to nail down the object. In this chart itself, you can see, right? So on the position, it has based on position, it has this potential energy, and due to motion of this hammer, the nail is nailed down the plank, and this is the kinetic energy. So both potential and kinetic energy is there, right? So basically, if you talk about, it is the sum of potential energy and kinetic energy. So energy, mechanical energy can be sum of potential energy, that is half of potential energy mgh, and the kinetic energy half mv square, right? The mechanical energy can be again of two types: elastic types, where the kinetic energy is conserved, and inelastic types, right? Elastic types means a perfect, when you release the thing, it will give you mechanical energy with no loss, right? But in real world it is not possible sometimes, and these are called inelastic, right? So friction can be another example. Friction, due to friction, the mechanical energy is reduced, or some is dissipated in form of heat, right? So this is about mechanical energy. Now, chemical energy. Now, chemical energy is defined, which is energy stored in form of bonds, right? All chemical elements, they react each other to form chemical compounds, or they will form different types of molecules, and between these molecules there will be formation of bonds, right? It can be ionic bond, polar bond, covalent bond, hydrogen bond, so many different types of bond, and these bonds store energy. Okay, breaking and remaking these chemical bonds requires energy, and energy either can be absorbed to break down the bond, or energy could be released by the breakdown of the bonds, right? So these are possibilities. Now it is also referred to as ability of chemical substances to undergo chemical reaction to transform into other substances. So it transform into other substances, right? So can A and B, suppose can reactant A and B will produce a product C, right? So it will transform into different substance, right? Energy and transformation and material transformation both are there, right? Energy that can be released or absorbed because of reaction between chemical substance is equal to difference of energy content of products and reactants, right? All of you know these facts. Hmm? Examples of chemical energy, you can think about batteries, biomass or wood. You are burning it to your homes. Some people of some of me use this in the rural areas. Petroleum is another form of chemical energy, natural gas, right? Coal. These are nothing but stored chemical energy which are used. Even our body uses a chemical called ATP, which is used as an energy currency for our body. Now, electrical energy. Electrical energy, all this electrical energy is coming from a particle called fundamental particle called atom, right? So atom has uh, three different type of two different type of charged particle of all of you know, protons, electrons, right? So electrons, they are usually the first participant in the electricity transfer because they are outside the nucleus, right? The movement of electron from one atom to another atom is resulting in electrical energy. And the electrical energy is supplied by the combination of current and electrical potential. And because of this, the difference, this is called potential difference, and it is also called as voltage, right? That is delivered to the circuit, right? So we have positive and negative terminals in between. There is a potential difference, and then this can be used to run a device in a circuit, right? So we have electrical circuits. Now, when electrical potential is converted into other type of energy, the electrical can, all of you know, electricity can be converted into different form of energy like light, bulb you are using, heat or heaters you are using, right? So all different uses are possible with electrical energies. Battery, solar cell, lightning, even the electric eels or the eels which are found in the water bodies, they also have chemical chemical electric system, chemoelectric system, right? So they can deliver shocks. Now, last, this is the nuclear energy. So nuclear energy is again, it is found due to the nucleus which is there. In each of every atom we have a nucleus, right? And nucleus is at the center of atom which holds it together. So either way, you can have two ways to obtain the energy of nucleus. Either you break the nucleus, or you join another nucleus to the current nucleus, right? So if you break down the nucleus into smaller particles, these are called nuclear fusion fission, right? And if you join two nucleus together, this is called nuclear fusion, right? So nuclear fission is example which is used in your reactors, atomic reactors. They are using nuclear fission. Even the atom bomb is using nuclear fission, right? And nuclear fusion is another source of potential energy where nucleus combine rather than splitting, and then they produce, of course they produce, release energy. The examples can be a hydrogen bomb, or our stars, right? So these are the examples of this nuclear energy. Atom bomb, nuclear power station, they use nuclear fission reaction, while hydrogen bomb, sun and stars, they use nuclear fusion reaction. So energy is precious. We cannot do anything about without energy, and it is possible to have a better tomorrow if we conserve energy. So this is all about our class today. Thank you all.